Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video we're going to continue on with the RoboHat version 2. So in the last video I mounted onto this particular board the resistors and capacitors that I had received, and I discovered I had the wrong size component for all of the INA 219s. So it's been a little, I had to order new ones, and it's been a little while, and they finally turned up, and this is what they look like. As you can, so let me see if I can get this to focus. There we go. This has got a manual focus on this microscope I'm using. So the eye is the INA 219 is the model, and it did take me a little bit of time to actually get hold of all of these. Of all the components for this project, I'm still missing the PCA 9685, and that's what that chip looks like. This is one I've recovered off another board, so I'm hoping to actually install that on the main board, either in this video or the next one. But at least I've got something to record. So before I can put this on, I really need to put some solder paste on. And for that I have my solder paste. And just to give you an idea of the size, there's my finger in relation to the size of the parts on the board. It's thumb and finger. Those parts are very small, which is why I'm using a microscope for this. My webcam just doesn't do it justice. Alright, I'm going to try and squeeze some of this out very carefully. Well, it's coming out already. Now this is supposed to be flux and solder. And I appear to have it running at a reasonable rate. I don't want to put too much on because it goes everywhere, I found out. And that tip is incredibly small when you look at it without the microscope. I've probably got way too much on. This is going to take me some practice, I think, to get these right. Okay, I think I've stopped that extruding. So my next trick is to actually put some parts on. Now, one of the things I did note when I was heating up and installing the resistors is that these parts tend to straighten themselves up when the solder melts. The solder tries to clump as balls on the pads on the copper, or the copper pads on the circuit board, which is going to make it look a lot neater when it's finished heating up. And 2 to go. That's a bit better. Okay, so next trick is to heat up the hot plate and put this board on the hot plate. And for that I'm just going to switch over to the overhead camera. Okay, so I've got this heating up. It's almost at 220 degrees C on the hot plate. It's very hard to tell, and even my thermal imager has trouble seeing that temperature because of the silver plate. But we will put this circuit board on and let it cook. So it shouldn't take too long now to heat that up. The solder is supposed to melt at 183 degrees. I'm hoping that looks pretty good. Alright, I'll switch back to the microscope. Okay, so I think these look alright. Hang on, let me flip my image. That's better. I will have to have a closer look under... Oh, I've got a bridge there. I will have to fix that one up. I've got too much solder just in here, so I'll have to clean that up a little bit. And there's a couple more like that. But mostly they look alright. A little bit too much on U8 and a little bit too much on the bottom side of U10. Probably a little bit not too much on pin 1 of U11. But I think most of them are actually pretty good. Alright, so I might do a little bit of cleanup on that. I might use my bigger microscope. I just can't record live off it. And we'll come back and we'll have a look at the other circuit board and see how that goes. Okay, so I cleaned up the solder joints around here. Used a little bit of solder wick. It's basically just braided copper. I soaked it in some flux before I applied the soldering iron, holding it with tweezers, and just used it to suck up the excess. Cleaned up all of the joints, and I think they all look okay now under the microscope. So I'll just move my solder out of the way. So the next part of this job is the through-hole components. So these are not the rest of the parts are not surface mount, and they include these. These are a triple layer by 4 right angle connection, and the idea behind this is our servos can connect onto these. Now the standard servo connector is just that little bit wider than a standard multi-pin connector like these are. So while these will connect on quite happily, this is only 2 rows obviously, when you start putting the servos in, they tend to want to spread out a little bit. So for that reason, we're breaking them into groups of 4, and that allows a little bit of room between the groups of 4, and they will all go on there quite nicely. This was something that was discovered by Adafruit Industries when they were making their PCA 9685s, and I've got one of their boards, or similar to their boards here. This is actually a Chinese knockoff board, and it was modified from the original one by removing the reverse polarity protection. Adafruit did not remove it when they modified their design. They moved the LED onto the other side and put a bigger transistor in for the protection. So let's start putting these pieces into place. So this one's actually a relatively simple job. Just push that on, and I'm going to put all of these in at once. Flip it over. I'm just going to support the back end with this. Turn on my soldering iron, and I need my solder. Okay, solder. Get my soldering iron. And I'll start on this pin at the far end. And I just want to have a look at that under my microscope for a sec. Hey, that's told the joint's perfect. It's alright. Do the diagonally opposite one for that batch. Alright, so that's the corners of each group. So I'm just going to go through and solder each pin now. Okay, that's all those pins done. So the next highest component on the board is going to be this. Now I was considering not using this, but the one I was considering not using was actually orientated differently, so it would give it a fairly high height by the time it was installed. This one shoots out off to the side, and it actually comes out over the top of the USB port on a Raspberry Pi 3, and I think the network port on a Raspberry Pi 4. So this does not extend past the full body of the Raspberry Pi when assembled. And since it's not much higher than the servo pins, I'm going to put it in and use it. For those of you who are not aware, I am planning on putting this into my Spot Micro robot, but it would be good for other projects like the MR4 robot I'm working on as well. Okay, so that's that one. Now the next tallest component on here is going to be the capacitor. So that's our negative side. Short pin is the negative, and our positive goes towards me here. And it gets soldered on the backside as well. And for that one, I'll use my flush cutters and trim those leads back. Okay, so that leaves us with one component left, and that's this one. That's the header that goes to the pins on the main board. So we've got the main board and the daughter board, and this gets soldered on the top side. Okay, that's the corner pins done, and I'll just go through and do the rest now. Okay, they all look good. Right, so that's the first of the two boards done. I didn't get that capacitor very straight. I can probably straighten that up. That's better. Okay, so that's the first board done, and I think I'll call it that for this video. In the next video, I'll populate the main board. I've got all of the chips for that, and with the exception of the PCA 9685 that I've ordered. For this first prototype, I'm just going to use this one. This is one that I recovered from another board, and that goes right there. So I'll populate that out with all the SMD resistors and capacitors. Then I'll go through, I'll put on the little tiny ADS 1115s there and there. The MPU 6050 goes down here. The MPR 121 fits into this spot, and the PCF 8574 goes into here. There's also a 24C 64 or 256 goes in here. So that'll be the EEPROM that is used. It's a I2C based EEPROM. It's on the I2C bus 0, connected back up through here, which is reserved for the Raspberry Pi during boot up. During startup, the Raspberry Pi OS will actually read in the contents of that chip to find out what's actually attached. And at some stage I've got to write the code that goes into that. And we can actually program that from the Raspberry Pi. Because it's an I2C device, we have a jumper that goes in here, or can jump onto there, and that enables us to write to it. So a write enable jumper. So that'll do for this video. So if you like these videos, don't forget to click on like, subscribe, and ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. It also allows YouTube to let you know when my next video is out, so you can go and watch it. If you'd like to support the channel further, I do have a Patreon account, and you can join my patrons VIP Go Lucky, All Access patron Jeff Jerd, my Builder patrons Alan Morales 45, Andrew Cardone, Airgar69, and Stefan Papist in helping to support the channel. If you've got any questions, feel free to leave a question in the comments below, or drop into my Discord. There'll be a link in the description, and you can ask your question there. If I can't answer it, someone else might be able to. And we'll see you in the next video.